Hello, it's me again. We're back here on More Fun Fixing It, fixing another broken and pretty disgusting Commodore 64. Feast your eyes on this. This is not one of my friend Paul's machines. This is one of my friend Henry's machines. He took this in, I think this was an eBay purchase, and he took this in and decided that he couldn't bring himself to touch it. No, he thought that I would enjoy bringing this one back, and I am going to enjoy bringing this one back because it is disgusting. I've just done a C64 repair on this channel, you probably have seen in the last couple of weeks, in which the inside had some 1980s fluff. Some nerd fuzz from the 1980s, vintage fluff, and that was pretty disgusting. And the thumbnail on that one it sold the machine all by itself. It sold the video all by itself because it just, it appealed to everybody. But this one, I've had a little peek inside this, has got the biggest dust bunny I think I've ever seen in my life. So let's pop this open so you can feast your eyes on this. What? Has it had something nesting in here? Oh, got a broken capacitor there. Yeah, there's your thumbnail. Right, so we've got a few things going on here. One is I can see some nastiness at the end of this capacitor here, and I'm wondering if that capacitor has gone. I will give that a measure. There's a lot of corrosion around the legs of the switch, so I'm assuming that the switch actually moves okay, but there's a good chance that that will be a problem. Oh, I lost my dust bunny. I might bag that and sell it on eBay. There's a lot of rust on the cartridge port and the RF modulator. There's some rust down inside here as well, and it is just covered in a layer of grime. There's stuff underneath here. I think what I need to do is get this out of the case and clean it or blow it outside maybe with some compressed air and a brush. And the screws are quite corroded. I might have to put those in some vinegar. There's definitely some water damage around this area over here. Let's have a look with the scope. You can see there's bits of rust around these connections. That's not a good sign. There's quite a lot of water damage around this area. That is the power switch. That's the other side of the power switch. And let's give this a little poke. So some of that is flux. There's often flux around here, but not all of it. I don't think the flux would have stayed like that. And so some of the board looks in poor condition there. And this is a joystick port. Again, this looks like flux, but all of this can't all be flux here. This is water damage and corrosion and scumminess. So that's all going to need cleaning up and reflowing. So have a look at this port. The solder looks in reasonable condition. These are some of the connections on the back of the modulator, and some of the rust has come through on there and on this one. It's very rusty. But this is flux, so that's okay. Broken component here. This capacitor has snapped off. Looking at the legs of the chips as well, there's a lot of rust on that PLA. This is the SID socket. There's also quite a lot of rust on those legs as well. it's going to be a mirror. Look at the chip next to it. This U6, there's rust on each one of those legs. It doesn't bode well. But going across, we're over on the ROMs now. There's a little bit of rust on that leg there, and some of those. But as we move across, seems to be more on these sides than this side. Yeah, there's some on these. There, it's everywhere. This is a CIA. And we have some more nerd fluff. It's like vintage candy floss. Just doesn't taste quite as nice. Ask me how I know. I wanted to show you over this side of the board. This capacitor here. So is that in there just corrosion from water damage, or is that the internal part of the capacitor leaking out? Is that electrolyte that's spewed out? And it's in the same place as I've had one before. The only other bad cap that I've seen in a C64 was this one. We have a lot of detritus in here. What is all of this? It's probably worth having a look underneath the modulator can. I'm not even going to try to rescue this can. This modulator RCA jack is gone as well. That's completely rusted. There we go. Brute force, a little bit of ignorance. There's stuff in here. Oh, I'm introducing stuff. But it doesn't look too bad inside. Oh, that variable resistor there is rusty on the outside, so that's not a good sign. That pot there is full of stuff. Yeah, that doesn't look too bad, so I think I might just remove this cap anyway and replace it before I turn anything on, otherwise it's going to cause problems. But first things first, let's give it some air. Right, that looks a bit better. I am going to, before I give this any power, just remove the SID as well. Keep that safe over there. Let's get this cap out and this glass encapsulated capacitor out. Right, I've got a donor board here, 250407, which I can take this 2200 microfarad cap out of here. It's a long chunky boy, that is. And I can find the same cap C37 here, which is it's not a glass encapsulated one, but it is it's going to be the right value. So I could put a new one in if I work out what it is, but I think I'm just being lazy, and it'll be just as easy to do it this way. Oh, I like recycling parts. All right, there's the old one. I'm not sure if that has leaked or not. I think it might. I don't see why it would have all of that crud there and not on anything else in this area. So let's test it against this one. Kindly donated by Ashley Heath. Right, this is the bad one. It's saying oh, hang on. Right, so for 2200, this has not got 2200 on here, but that's half an ohm. And what's the voltage rating? 16 volts. It should be for 1000 microfarad. it should be 0.09 ohms. That's an order of magnitude higher. And for a 4700 microfarad, 0.2 ohms. Let's try this one. Ha, 0.3. Well, this is better, but I don't know how much better, but I'm sure it will be fine. Those are the bits of capacitor that were left over. That's the new one. So 102 is 1 nanofarad. 1 nanofarad or 1000 picofarad, I think it is. Yeah, 1 nanofarad cap. Yeah, I'm just going to put that in there. I could use a new part, absolutely, but I'd have to go and find one. So this would have just been a decoupling cap. And not important. I'm almost certain it would have worked without it. But worth replacing anyway. It's time to plug it in. I'm going to give the power socket a clean with some contact cleaner before I ram it full of plug. That was unnecessary, wasn't it? Okay. And video. Well, that's crusty. Let's see what we get. Black screen. Nothing on fire. Cartridge port needs a clean. I'm just going to get this cartridge first. Right, so my des test switch in there. Let's see what that does. Nothing. Oh, if I press reset, it goes white. I'm manipulating the cartridge in the slot and getting different behavior. So I think the cartridge slot is pretty badly cooked. Looking at the back of the pins as well, there's a lot of detritus and corrosion in there. And looking at these pins, I'm not sure if I'm going to be able to show this. Right. Well, they don't actually look too bad from this angle. I think the light is actually making it look a lot better than it is. This one here, for instance, with the naked eye, looks quite corroded. So with that one there on this side, and the left one side of this one. Yeah, there's some here as well. These ones are not looking good as well. And that one there. And this one on the end here. And that one there. And then, and that one there. What I think I'll do is just remove the cartridge port altogether and put the one off this donor board in. This one is looking much shinier. That's what it should look like. Right, so let's take the one off the donor board first. which has got longer pins than the one we're working on. Why did they solder that one point in? No, let's get all these out first. I think my soldering gun needs a clean. Come on, focus. It's not meant to have solder in that nozzle there, in that hole. I've just got this one to remove here. But before I do that, I'm going to desolder all the nozzles, all the points on the other one, because I need to change the nozzle on the desoldering gun. Alright, nozzle change time. I do like how easy it is to change the nozzle on this. Give that a minute to warm up. I'm setting it to 2 on the dial on here, and that is 400 degrees. It's still not big enough. Damn it. Have to get the rest out with wick. Oh. Well, stuffed up a little bit there, but I don't think I've done any damage. Let's give it a clean. Yeah, the traces are fine. They're all nice and loose. That's the cartridge port itself off. I'll have a look at the other side in a second. Now the actual, sorry, the shield for the cartridge port. This bit, the actual cartridge port itself is taped to the board for extra strength. So I'm just going to slide plastic spudger along here just to break that tape up. Everything's free on the top here, so I can pretty much go wild. You can see the tape along here. I'll have to remove that and replace it. And you can see here the, come on, focus. The rusty shield is off as well. It's rusty underneath. So that port is done. Let's get the other one off. We made a clean bit. Right, the solder points look a bit crusty, but it doesn't matter so much on the top. Make sure they're clean on the bottom before I solder anything to this. And these are all good on the bottom. This is fine. This side was protected by the solder. So I've got to get this in. There is a bit of tape left on the bottom of this, but I don't think that's going to come off very easily, and I can quite happily leave that there. Just going to make sure that the port goes into the correct place nice and easily. It does. I just need to put some tape across there. Super sticky stuff. That's not going anywhere. All right, did that make any difference at all? Right, the next thing to check if this doesn't, that's come on, make a difference is voltages. Well, I need to put that shield on the cartridge port as well, but I'll do that after. Right. No difference. Right, let's look at voltages then. We have 5 volts and we have 12 volts. And we have, that's the AC side. Ooh. Yeah, we've got some voltage there. And only, yeah, those edge connectors are very, yeah, that's fine. They're very corroded. Let's just have a quick look at .83 is a bit low. Yeah, the PLA is up to 60 degrees. And we have some hot RAM chips. Well, not hot, but hotter than the other ones. They're all the same brand as well. This one here at U23 is especially warm. No, warmer than the others. That's not normal. That ROM is at 50 degrees as well. It's getting quite hot. It's nearly 70 degrees on the PLA. So the PLA is almost certainly toast. So I'm not even going to do any further testing. I'm just going to take the PLA out because when it's that hot, it's fairly obvious that it's broken. I don't need to be probing. It's falling through the board. Lovely. I don't think that's going to work in anything. But I will get my test machine and try it out. Always check that the test machine is working. Yep. Very crusty PLA in my nice clean socket. And a black screen. Okay, so definitely a bad PLA, which we can mark straight away. No surprise there, it's always the PLA. Put the socket in. Let's give that a clean first, just because this board is so disgusting. Might as well take the opportunity to clean bits that I won't be able to get to easily later. I like to solder the second to last one when I'm doing these corners, because the end ones are often power rails or ground or something like that. I'm just lifting it up and reflowing that. And this end. They're just easier to reflow. Okay, I'm going to put my good PLA in here. See if we get any further. I suspect that there are multiple chips in this board that have failed. This could turn into a long day. Right, so still a black screen, but do we get anything with diagnostics? Yes. Oh, okay. We get quite a lot of badness with diagnostics. So bits, well, it's easier to count the good bits. So bit 1 and bit 3 are good. What is grey border fail testing the VIC? Really? We haven't looked in here. It's a very reluctant lid to come off. Fail testing the VIC. Does it repeat the test? No. Different every time means it's, whoa. Bit 1 and 2. Bit 1 and 2. Okay, it is the same every time. Yeah, I just had my solder underneath this side here, and I must have been shorting something out. Oh, bit 1 and 3. Bit 1 and 2. I wouldn't expect the, well, the socket might be bad on the VIC-2, so I expect we should check this in my test machine. It looks pretty good under here, so I don't expect the socket to, yeah, the socket looks fine. Does concern me that it was coming up with a VIC-2 error though. Let's just test this again. My PLA socket is getting looser and looser because it's been used so many times, but it's just carries on working. So I'm not going to change it. I've been asked if I want ZIF sockets for a ZIF 64, but I'm okay with this. This is fine. It's easy to change these sockets if I need to. They're very cheap. And ZIF sockets don't last forever either. Okay, that's still booting with the other VIC in. Is it an R3 VIC? Yeah, an R3. It's a decent VIC as well, yeah. Oh no, this is... Well, it's happy. Okay, so the VIC is okay, that's good. It could be one of the associated chips in the, you know, one of these chips here. PLA back in. The VIC-2 back in. Actually, I want to try normal diagnostics. Doesn't hurt to get a second opinion. Ooh. Nothing on that one. Right, dead test. This is giving one flash. Now, this is the strength of des test against dead test. Des test will show you all of the bad bits, and dead test will show you one bad bit at a time. So I could pull the chip, replace it, put another one in, test it again, still bad. So one flash is U24, which is bit 7. I'm pretty sure that was one of the ones. But let's go back to des test. Yeah, bit 7 is definitely one of the ones, but oh, what, all of them now? So bit 7, U24. No, sorry, it was U12, not U24. Which is this one here. So the one that was hotter than the others was one of these ones down here, which is U22. So I propose we take out U12 and then see if that makes a difference. Let's see if it makes a difference now it's actually running. CPU's good, VIC's good, PLA is now good. Oh, that's interesting. So, okay. These two on the end here, U9 and U21, are almost stone cold. The others are normal warmth. I say normalish warmth. PLA is still 50 degrees. So are these two the ones that are showing good there, bit 1 and bit 2? Bit 1 is U9 and bit 2 is U22. Oh, it's U21. That's a shame. Bit 0 would have been nice. So U9 is showing as good, and bit 2, U22. So those two are showing as good. So we need to look at all of these ones. Yep. 1, 2, 3, 4, 5, 6 chips. So I'm going to pull out the one that dead test said was bad first, U12, and see where we are with that. 330 degrees and 99% airflow. Right, 4164. Failed. Oh, it's passed. On 300 nanoseconds. What are these rated? 150. No, it's failing on 150. Right, try it in the other tester. I'm still not entirely trusting this one because I'm not used to it yet. I like a straight good or bad. I do like this tester. Serve me well. See, this is interesting. I'm going to say that's going to pass. Yeah, that's passed, but is it good enough to work in a C64? It's a very interesting problem. There's no perfect chip tester. I'm not going to get out the Retro Chip Tester Pro for this. 4164. So it's failing at 100 nanoseconds. It's failing at 120. It's failing. That failed then at 150. And it's passing at 200. It's kind of a marginal chip. So what if I put a socket in there and put a known good chip in there? Will that then pass that bit as good? Is bit 7, which always was always failing. Okay, replacement chip. 4164. Fails on that as well. This one's doing exactly the same thing as the chip I took out. So it's going to be very interesting to see what it does when it's in here. I don't think it's going to make any difference at all. I think there's an addressing error somewhere. And probably most of the chips are okay. Hit it. Yep, bit 7 is still bad. The most likely culprits here are U13 and U25. The 257 multiplexers. But maybe the fail testing Vic error is giving us a clue as well. All right, I'm going to have to get the scope out on this one. But it's time for me to eat. I'll be back in a bit. So I've had a poke around. I had a little look with the scope, and there wasn't really much that I could see that was obviously a smoking gun. When I was checking the multiplexers, they looked fine. I also checked U16, which I know is connected with things, and that looked okay as well. It kept crashing, and every time I pressed against the board, it would crash. And I thought that there was something that I was manipulating, so I started poking around the board, and you can see it's crashed now. But it wasn't me poking the board, although it looks like I've just touched it and it's crashed. It's not, it's just if I don't touch it at all, it will crash. And so I got the thermal camera back out, and you can see that the PLA here is about 51 degrees, but the CPU next to it is currently about I've turned it off, so it's not going to get very warm. It's warming up 45, 46, 49, 50, 51, and it's crashed. I've got a white screen on capture. I should turn capture off. That's not helpful. Okay, so you can see capture now. If I turn it back off and turn it back on, it starts to run, and then as soon as it gets a little bit warm, let's put my finger on it. No, it's not going to crash this time. All right, so we're up to 52 degrees and it's crashed. The temperature is still going up. If I heat it up, it's 140 degrees, I think this is. Yeah, 140 degrees. It's crashed. Let's get this chip nice and hot. All right, so it's about 71 degrees. If I turn it off and turn it back on, I don't think it's got in, far enough there to do anything. This was doing this much more reliably a minute ago. And one of the problems I've got here is I think there are multiple things wrong with this board. I think that one of the CIAs is at fault because U2 is hot well, not hot, but 45 degrees, and U1 is only 35. And there's quite a big difference between them. There's probably a bad ROM in here as well, and there's probably still bad memory. There's no MOS chips, no MOS logic, so that's a good thing. It's not doing it now. So what I did was actually spray it with an upside down air canister, air duster, and then it started working better. But it might not be that. Okay, I'm re-baffled. I thought I had the solution. I thought it was going to be the CPU. And it doesn't seem to be. So I'm going to leave this running for a bit. I'm going to let that CPU heat up naturally inside and see what temperature it gets to. Then I'm going to hit it with some air duster again and see if I can replicate the fault. I've had a little play. It's the next day and I've been poking around and seeing what I could find. So all that I've done so far, to recap, is change the PLA, which was definitely faulty. I took this chip out because Des Test said that one was definitely dead. Although looking at the results of Des Test at the moment, they do keep changing. So there's no consistency there, which is always a good indicator that the RAM is probably not the problem. It might still be a problem, but it probably isn't the actual big problem or the one that we need to address first. But if I keep cycling this, see that this time it's all gone red. Sometimes it will come up with one green bar and then it will disappear. It's quite strange, very peculiar. So I'm less inclined to think it's the memory, but I'm not ruling it out. Now, one of the things I have found looking on the oscilloscope is that the data lines, actually the first thing I did was doing my due diligence. I started checking the reset on the CPU. So if I turn it off, we're on low, then it waits and then goes high. The reset is perfect. The next thing to check is the clock, and we've got a really good clock coming out of the CPU. The clock going into the CPU is equally good. And then after that, I started scoping, going down this side, and these are the data lines. This is D0. That's the first one that made me go, oh, that's not right. This is D1. That doesn't look right. This D2. That doesn't look right. And D3 doesn't look right. But we go on to D4, and that also not looking brilliant. I wonder if it's different. I didn't have Des Test in when I did this earlier, so let's try again without that. So okay, this is what I was seeing. So D0, D1, D2, and D3 are all arguably bad. There's not being pulled back down to ground, and they just don't look like data signals. That in fact. Continuing down, that actually looks like a good data signal. There's nothing wrong with that one. I would say that that's okay. These ones are weird. Not sure why they're just doing that. And then we're off of the data. It did look like the first 4 data signals, D0, D1, D2, and D3, were bad to me. And the only place on the schematics I could see that had just the data signals, D0 to D3, was the color RAM, which is here. And you can see there, D0 to D3. But if I go down here to the color RAM, what we're looking at there, pins 11, 12, 13, and 14. So it's a 18-pin chip, so that's 10. And 11 actually looks okay. 12, not perfect, but not terrible. 13, 14. So I don't think it's the color RAM, and it's not often the color RAM in my experience. So we've got bad data signals on the CPU, but not the color RAM. But the color RAM, actually the data signals go through U16, this 4066, and the VIC2. So they don't actually just appear on the data bus. The data bus comes, this blue line here, and D0 to D7 go into the VIC2 here, and then come back out as 8, 9, 10, and 11 into these points here, and they're counted as 0, 1, 2, and 3 on the color RAM. Don't ask me why. But the point is that they're not directly connected to the rest of the data bus. D0 to D3 are not connected to D0 and D3 on the memory or the ROMs. So the memory here has D0 to D3 here on these chips, U21, 9, U9, U22 and U10 are D0 to D3, but those are also connected, see this blue line here, to the character ROM, the kernel ROM and the basic ROM, as well as the CPU. As well as that, the blue line here, this blue line on the left here is the data line, the CIAs, so the CPU here is connected to the data line, goes down to the CIAs, and it both CIAs, and then continues onto this second page. So there's a lot of stuff connected to the data lines, and I've scoped all of the, I scoped the data lines on the CIAs, I scoped the data lines on the ROMs, and they all look the same as they do on the CPU. They look terrible. And then I noticed something different down here on the memory, going back to the memory. So the chip that I took out, 12, is data line 7. And if I scope the data line on that one, that doesn't look terrible. But if I scope the one next to it, oh, that doesn't look terrible either. All right, U10, really bad. U10 and U9, okay, they're good, two good examples. U10 and U9 are really bad. And yeah, there's U9 and there's U10 on data lines 1 and 3. So what about the other two, 22 and 21? Let's check those. U22 is here. That doesn't actually look too bad. And U21 is bad. It's really confusing. Well, it's not confusing, something's broken, but this is the point of a repair where you have to say, I'm going to guess it's this, because it's exhibiting a trashed data bus. There's something killing the data bus, and it's affecting the CPU, the ROMs, the CIA, and most of the memory. But there's nothing to say which one it could be, apart from this CIA was getting warmer than this one, and the kernel ROM was getting warmer than the other ones. But the kernel ROM does tend to, because it's working harder than the other ones. Again, not the VIC, but I've tested the VIC. This is a known good PLA, and it's not an addressing issue, so I'm going to discount most of what's going on down here. Right, I had something wrong here. Going back here to this 4066 at U16, the 4 data lines do go into this side of it. So not only are they connected to the VIC2 here, but they go in through this 4066 here and then come back out to the character ROM. So I should scope pins 1, 4, 8 and 11 on U16. 1, 4, 8 and 11 on U16. Yeah, it's bad. 4 doesn't look too bad. 8 is bad. And 11 is bad. Okay, just because it's smaller and I'm going to pick on it, I'm going to take that 4066 out and test it out of the board, because that one could be the whole problem or part of the problem. You've seen enough soldering for now, so I'm going to skip ahead till when I've got it out. Right, that tested normal. And thinking about it, it was a bit of a long shot because some of the other chips were showing normal. Some of the chips on the other data lines were also not normal. So I'm not going to put a socket in here because this board belongs to Henry and he doesn't like sockets. So I'm not going to socket absolutely everything. So sadly, we are now back down to guesswork and instinct. So I am going to go with the thermal camera this time and take out the I could take out one more memory chip, one of these that is actually showing faulty. I think it was a U9, wasn't it? Yeah, U9 and U10 are both horribly bad. Let's take one of those out just to double check, because taking out a 16-pin chip is a lot easier than taking out a 40-pin chip. Ah! Okay. It's a bad chip. Okay. All right, so I'm going to take out the one next to it as well, because that was. Or should I just turn it on and scope those lines? See, it could just be that one. I don't think it will be, but it could be. Okay, so that's still looking bad. Something is still crashing that bus. Okay, so all of the ones that look like this are coming out. So we've got 10 is definitely is, but 11 is not. We've already done 12. Now 21, yes. 22, no. No. And no. So it just needs to take out 10 and 21. Are the only ones that really still look dodgy. Right, let's try the next one. Yes. Okay. 21 was the next one. I should really plug it in and test it. Yeah, let's test it first. That's the sensible thing to do, because it could be that chip that's causing all of the problems, all of the rest of the problems. No, it's still there. 21 still needs to come out. It's probably absolute pure blind luck that I took out the only chip that was not faulty. All of the rest of these could be faulty. Bad as well. Right, now what do we have? I think there are problems elsewhere on the board. Yep, still looks bad. I wonder if Des test gets any further without those chips in. Okay, still a very similar thing. Okay, we're back to guessing. Oh, with Des test in, getting some much more normal looking results. The data lines look better. Still getting inconsistent results on Des test as well. Okay, well, in that case, let's put, I think the memory that's left in here is okay. I'm going to put some more sockets in here, and then I'm going to remove the CIA. If it's not this one that was getting hot, then I'll remove the CPU. And if it's not that, then the kernel comes out next. Can't see any other differences between them. Oh, I need to check the chip select lines. Right, yeah, so we've got some activity at the start there on the character ROM. We've got fairly normal activity on the kernel ROM. The basic ROM, a burst of activity at the start, and then nothing because the system is crashing and there's no memory in it as well. Let's stick the memory in and see if that behavior changes. Yeah, let's put the sockets in and then see where we are with good memory in it. So I know I've got one good memory chip here that I took back out. So I'm going to put this one in, and I've got to find two more. Okay, two good memory chips. Now what happens? Let's Try without that first, without the diagnostics first. See what it does. No, oh yes, a change in behavior. That's good. And that is pointing to one of the ROMs, I think. Yeah, that's character ROM. Whoa, we are further ahead. Still giving me that all of the bits are bad. Curious what the other diagnostics do now that this can get further ahead, and I can discount the ROMs using this one. Indeed, yeah, character ROM. Oh, and CIA 1 is very bad. This is good progress. This is very good progress. So, all right, it's still saying we've got a lot of bad ROM. Okay, so I've changed U21. No, I've changed U9 and 10, which is saying are okay, and it's saying U21, which I've changed as well, is okay. But it's saying all of the others, including U12, is bad. Interesting. But it also says that, oh, it said something about the kernel ROM. Let's do pass the RAM checks. It's saying the PLA is bad. It's saying the ROMs are okay. U7, U1, and U2. We know that one of the CIAs is bad. U7, which is the CPU. Okay, that's good. Well, we know the PLA is good, and I think that the PLA is being trashed by the CPU. So let's get the CPU out, because that is fantastic progress. Once you can get to a point where things can show you the way ahead, you feel a lot more confident about a fix. When you're guessing and hoping, then things don't feel so. You don't feel so confident. You feel like you're flying in the dark, flying blind. Right, test machine in. I need that PLA. Make sure this works. Yep. Does it work? Ah, that's quite interesting. It's failed in a similar way. Now it'll be interesting to see if it still has similar failure modes. So it's not picked up that U7 is bad yet. That's not affecting the CIAs. Does this affect the memory if I do the full test? I won't even start. It's saying this, so it's just a CPU, and it's not picked up on that diagnostics. If it flags up some bad memory here, that's going to be reassuring, because then I'll know that it was the CPU affecting things, and maybe the memory that's remaining in the board is okay. Maybe. I think that's crashed. Yeah, that's crashed. Look, what does des test do? Crap, I dreaded ROM check some mismatch. But that's coming up with the same grey border, but it's not indicating any memory is bad. Okay, so let's put a good CPU in the other machine and see what happens. So I've got a spare CPU here, but I'm just going to check it in my test board just to make sure that it is okay. Looks good. Just give it a blast of des test switch. Yeah, look, that's the colours that you're supposed to see. Okay. So that's got another bit of board I can clean. Sorry, Henry, I made another clean bit. Okay, so we have a new CPU. Let's see what that does. It's kind of working. Well, we've got basic screen now, so the basic ROM is okay. We've got characters, so the character ROM is working, and the kernel ROM is working because the machine is working, but there's still some bad memory. Right, so des test. Oh, it's still showing all bad bits and a grey. What? This is very, very weird, unless it's something to do with the cartridge port. Oh, I'm on. What was that? That's interesting. Bit 2. 2 is U22. That one. Very consistently as well. I wonder what dead test says. Dead test is, oh no, 1, 2, 3, 4, 5, 6, 6 flashes. 2, 3, 6. 6 flashes is U22. So that's agreeing. That's still saying U7 is bad. Or the CPU. So if this comes up as U22 is bad and all the others are okay, that could be quite interesting. But the CIA is still bad. Yeah, the U2 is counting up, but the first one is completely trashed. So that's going to have to come out. And the memory test has crashed. Okay, so I think the next thing to do is to take out U1 and test that in another board. I'm fairly confident all the ROMs are okay, and I don't know, I think U22 might be bad, but it could be something on the CIA that is trashing the data bus still. Let's have a look at the data bus actually. So that looks normal. Yeah, that looks normal to me. Yeah, there's nothing wrong with this chip. I'm fairly confident that that is an okay chip. U22 is actually okay. I think it's the CIA that's causing that to be reported as faulty. So I'm going to take that out next. Okay, I've taken out the CIA and I've put in a new socket, but I'm going to put this one aside and test this in the other board. Oh, always check. Always check. No PLA. Right, so we've got a working system. Let's pop this CIA out. Put this one in with its really short legs. Let's put it the right way up. What does that do? Yeah, that looks familiar. Okay, so that's another chip. What are we up to now? Got 3 dead RAM chips. A dead PLA and a dead CIA. I haven't checked the SID yet. I can't imagine that the SID has survived. It's one of the most fragile parts of it, but we're going to test that last. Oh, and a dead CPU. So we've got dead CIA, dead CPU, dead PLA, and so far 3 dead RAM chips. Right, PLA back in. Working CIA. And what does that do? That looks better. Okay, what about des test switch? Hey. So a bad CIA was giving it a bad VIC problem. Might need to send you this CIA, Matt. Okay, I'm going to let that run through the whole of the max test. Sorry, the switch test as well. So it's just done the max test. It's switched over to the switch test now. It's showing the ROMs are good. That's good. It's counting up the CIAs together. That's good. But I just want to let it run through and do a full test of all of the memory before I do anything else. Then I'll put in the normal diagnostics cartridge and check the SID. I'll come back when this is finished. This takes quite a long time. Right, so all the memory is really good. Look at that. That's passed and it's going to go round again. Let's take out that one, put this one in. We already know the memory is good, so I'm going to switch it over to no RAM check. Right, so let's put in a SID or the SID, which has got incredibly crusty legs. Really, really crusty, and one of them's rusty as well. Yeah, this fiberglass pen is not doing it. I need something more abrasive, a brass wool or a brass brush. Okay, I'm gonna give the socket a spray of contact cleaner, a good dose, and hopefully that will be good enough to make good contacts. But I won't give up on it if it does come up as faulty on this. Let's try that. Nothing. Right, it's a bit of what's this? 240 grit paper. Yeah, it's leaving quite a lot of rust behind there. I'm gonna replace that socket as well because it looks really bad in there. I've never seen a chip with such corroded legs. This is incredible. I'm going to just try it again in this socket. It should at least have a chance. Nothing. Oh. Right, in the other board, see if it makes a noise. There's a lot of stuff going bad there. Sure, it's not all like usually like that. Okay, that SID's not happy. Oh. Why I had no CIA in there? I'll give it one more chance. Right, that looks better. Come on, make a noise. Not even a bit of a noise. That SID is dead as a dodo. So normally at this point of the proceedings, if this was one of Paul's machines that I was repairing, I'd be scavenging parts from all over the workshop. But sadly, this is Henry's, and now he knows what he needs. This as usual, the other side looks okay. I don't think the microscope was actually recording them, but okay, so I've cleaned up all the edge connectors as best I can. Let's put some chips in and a harness and then see if it works. CIA, a half working SID, but it passes diagnostics. And a PLA test harness. Okay, let's go. Now, why is that not working? That's weird. Okay, the controller port is concerning. I'll swap these over. It might just be my test harness. Hey, where's my harness? Full clean diagnostics now. So what I need to do now is put this back together as much as I can. I'll put the lid back on the VIC-2 with some fresh thermal paste and rebend the heatsink. But then I have to take out the CPU, the PLA, the SID, the CIA, 3 of the RAM chips, and send it back to Henry. And then he still needs to do something with the outside, because I'm not touching that. Do your own cleaning. But you'll be pleased to know, Henry, it's still got some case clips intact, so you should be all good. Although you've got your nice new bamboo printer for your birthday, so you could always print some case clips out if you need to. Right, I enjoyed that one. Thank you, Henry, for letting me loose on this. That was good fun. It's always fun when you get something with 7 bad chips in it all at once. That might be a record for me. I'm not sure. Yeah, you'll have to find the spare chips for this one, because I haven't got any. They all belong to Paul. Right, that's it for this one. I'll see you in the next one. Bye. God, I've got to edit loads of that now. Cut all the bits where I made mistakes and don't show my workings.